Hello guys, welcome to this tutorial. Today we're going to be talking about the Pythagoras theorem. Now just hearing Pythagoras theorem can sound really complicated to most people, and it's not really as advanced as it sounds. It's basically one of the core concepts of geometry, and which is also a fundamental of trigonometry, and it basically explains the relationships between the sides of a right angle triangle. Now a key note is that I mentioned the triangle has to be a right angle triangle, because most people tend to think that the Pythagoras theorem also applies to triangles, which is not true, because a triangle can come in different shapes and sizes. A triangle could look like this, it could look like this. Not all sides has to be equal, and the angles between the lines may vary. Now I apologize that my lines are not straight, and that is because I don't have access to a digital ruler, but I'm going to try to make them as straight as possible. But now these are triangles, and the definition for a triangle is basically three lines that connect to each other and that there is an angle between them. Now in these triangles that I draw here, none of them really has a 90-degree angle between them. And what is a 90-degree angle? For something to be a 90-degree angle, we have to have two straight lines that connect to each other, that are connected or intersected, and this is meant to be straight, by the way. And I apologize for future cases where I don't draw straight lines, but we have two straight lines, and the angle between these two is 90 degrees. And now if we call this side for A, if we call this side for B, and draw a line that connects A to B, and then this line we're gonna call it C, and that is our hypotenuse. And so this is the height of the triangle, this is the base of the triangle, and this is the hypotenuse of the triangle. And so I'm just gonna draw it all over again. Now once again, the line is probably not gonna be as straight as it ought to be, but just pretend these are straight lines. I'm really struggling here. So a straight line, let's see. Right, so A, B, and C, and it's a 90-degree angle between these three lines. And so, and the formula for Pythagoras theorem is a squared plus b squared equals c squared. Now you're probably thinking, where does all this square comes from? And it literally comes from the form or the shape square, like a shape where all sides are equal. So let's say the side of this square is, one side of this square is 4, and to calculate the area of a square, it's basically, just 4 raised to the power of 2, which is 16. And how does that apply to a rectangle? Now let's just imagine we have a square. I'm just gonna draw imaginary squares on top of the lines of the sides of the triangle. So so the sides of the triangle make up for one side of the square. Now once again, we're gonna assume all these are straight lines. So all right, so, and all this is straight lines, and like I said, this is a square here. We have one square here, we have one square here, and we have another square here. Now if this side was let's just say the length of this side is 5, and the length of the base is 4, and the length of the height is 3. So what that is going to mean is that 3 square plus 4 square equals 5 square. Now Now back to our squares. So to really understand why we use squares here is that we're gonna just imagine that this line here is the side of the square, and you remember, to calculate the area of a square you have to take the sides, one side raised to the power of 2, and that is exactly what we've done here. So in this square here, to calculate the area of this square, we take 3 raised to the power of 2. To calculate the area of this square, we take 4 raised to the power of 2, and to calculate the area of this square, we take 5 to the area of 5 raised to the power of 2. So the definition of, or these sides of the triangle relate to each other by taking the square of the sides. So the square of A plus the square of B is going to equal the square of C. Now we're going to prove that. Let me just erase this. Now we're going to prove that by calculating calculating the results of this. So 3 raised to the power 2 is 9, 4 raised to the power 2 is 16, and 5 raised to the power 2 is 25. And we can see that what's on our left is going to equal to what's on our right, what's to the right of the equation. So 9 plus 16 equals 25. And now that we understand what the Pythagoras theorem basically is, we're gonna do a few exercises, and which is gonna help us understand better and to be able to do exercises or calculations related to the Pythagoras theorem. So we can have a triangle that looks like this. Now all sides are straight lines once again, and we have a 90-degree angle between them, 5, 12. So the length of this side is 5, the length of this side is 12, and we're just gonna call this one C, which is the hypotenuse. And we know that a square plus b square equals c square, and we're just gonna substitute a for 5. Now it really doesn't matter, this could be 5 and this could be 12. The position of a and b really has no influence on what the answer is going to be. Just that the only criteria is that we have c to the right of the equation, and the sum of a and b, the sum of the squares of a and b is always going to equal to the sum of c squared. And if it doesn't equal to the sum of c squared, then it's not a right angle triangle, and the Pythagoras theorem cannot be applied. So back to our exercise, 5 squared plus 12 squared is going to equal c squared, and we're going to calculate the results of this. Is 25 plus 144 plus 144 equals c squared, and 25 plus 144 is 169 equals c squared. Now I'm just going to turn this around so it's more readable. So c squared equals 169, and to calculate c, all we have to do is take the square root of 169, and we are literally trying to find out what multiplied by itself is going to give 169, and the square root of 169 is 13, which means that the length of this side is 13. And since the sum of the square of 5 and 12 equals the square of 13, then we have proven that this is a right angle triangle, and we have also calculated the length of the hypotenuse. Now to another exercise, and in this triangle we have now this doesn't look straight at all, but I'm gonna assume it's a straight lines, and we have 9 here on this side, a 90-degree b, and 15. So we're gonna start with the formula: a squared plus b squared equals c squared, and substitute plus b squared equals c equals 15 raised to power 2. So now we unlike the former exercise, we know the length of the hypotenuse, and we know the length of one side of these two. So we're gonna find the length of the other side, and 9 raised to power 2 is 81 plus b squared equals 15. And if you're used to working with equations by now, you're gonna know that we need to have this alone on the left side, and we're gonna have b squared equals 15, oh I forgot my square, 15 square, which is 225 minus 81, which is 144. And so b squared equals 144, and b equals the square root of 144, which is 12. So the length of this side is going to be 12. Now that is that about this exercise. Now we're gonna do 2 more exercise in which we have to, because we can get exercise where we have to prove if it's a right angle or not. And since Pythagoras theorem always only applies to right angles, we can prove if a triangle has a right angle by applying Pythagoras theorem. So we have a triangle here. One side is 26, because now we aren't exactly sure, this triangle doesn't exactly look like a right angle, but we're still gonna we will have to try that using the formula. So we know that a square, and by the way, this is even though it doesn't look like the longest side, this is the longest side. So we have a square plus b square equals c square. And we're gonna substitute now, and we're gonna put 10 square plus 24 square equals 26 square, and that is gonna be 100 plus 576, which is gonna equal to 676. And we can see that 100 plus 576 equals, this one is 676, which means that the relationship between this the Pythagoras theorem is valid here, and thus this triangle is a right angle triangle. Now we're gonna do another exercise where we're gonna have to prove if the triangle is a right angle triangle or not. So we're gonna have a triangle, triangle here. One side is going to be 8, the other side is going to be 15, and the other side is going to be 16, and the longest side is going to be 16. So back to our formula, a squared plus b squared equals c squared. We're trying to find out if this is a right angle triangle by using Pythagoras theorem. So substitute a square plus 15 square. 8 square plus 15 square is supposed to be equal to 16 square if this is a right angle triangle. So 8 square is 64, 15 square is 225, and 16 raised to the power 2, 16 square is 256. Now you can see that 64 plus 225 is not equal to 256, but instead equals to 289, which means that this angle is not a right angle triangle. And so now we've worked with cases where the sides or the triangle is a right angle triangle, when we've worked with a case where the triangle is not a right angle triangle. And we've also gone through what the Pythagoras theorem is all about. I really hope this helped you in gaining a better knowledge and understanding of Pythagoras theorem, and in the future we're gonna work with more exercises that is gonna help us in further understanding triangles, as well as the relationships between the sides and the angles. And that is where we're gonna get into things like sinus, cosinus, and tangents. But thanks for watching, and I'll see you guys in the next video.